In a locomotive, the maximum magnitude of the unbalanced force acting along the perpendicular to the line of stock is hammer ball. Tractive force. The resultant unbalanced force due to the cylinder along the line of stock is known as tractive force. Swaying force. The couple has swaying effect about a vertical axis and tends to sway the engine alternate in clockwise and anti-clockwise direction. Hence, this couple is known as swaying force. Hammer blow. The maximum magnitude of the unbalanced force along the perpendicular to the line stroke is known as hammer blow. Swaying couple is maximum or minimum when angle of inclination of the crank to the link of a stroke is 135 degree to 315 degree. Swaying couple, the unbalanced forces along the line of strokes of the two cylinder constituent a couple about the center of line y wide between the cylindrical cylinder. This couple has a swaying effect about the vertical axis and tends to sway the engine alternately in clock and anti-clockwise direction. Hence, the couple is known as swaying couple. The maximum swaying couple is plus minus 1 by root under 2 into 1 minus c m omega square rl. In dynamic analysis of planar mechanism, the equivalent offset inertia force may be kept at a distance h of h is equals to k cube alpha by fg. Equivalently, offset inertia force is given as h is equals to kq alpha fg. The resultant unbalanced force is minimum in reciprocating engine. 1 by 2 of reciprocating masses of balanced. The resultant unbalanced force is minimum in reciprocating engine when half of the reciprocating masses are balanced. The resultant unbalanced force is minimum in reciprocating engine when half of the reciprocating masses are balanced. For cylindrical symmetrical inline engine is shown in figure. Reciprocating weight per cylinder is R1 and R2 and the corresponding angular deposition of the crank are alpha and beta. Which of the following equations should be satisfied for its primary force balance? तो A1 cos alpha बराबर R2 cos beta. Hammer blow in locomotive result is tendency to lift the wheels from rail. Hammer blow amount has to be limited in order to avoid the lifting of wheel from the rail of locomotive. In locomotive where the primary force are partially balanced, the maximum magnitude of the unbalanced force along the perpendicular to the line of a stroke is known as hammer blow. The secondary force in a crank piston mechanism is arise due to obliquity of connecting rod, acts at double the frequency as that the primary force, is smaller in magnitude than the primary force. Piston have mass 3 kg executed the pure simple harmonic motion whose displacement in meter is given by x is equals to 0.05 sin 10 t. Its inertia force at time t is equals to 0 will be. So x is equals to 0.05 sin 10 t. Here x naught x first differentiation of x is 0.05 10 cos 10 t. डबल डिफ्रेंशिएशन करेंगे तो माइनस 0.05 10 इंटू 10 साइन 10 टी और f इज इक्वल टू एम इंटू डबल डिफ्रेंशिएशन ऑफ x. तो यहाँ पे वैल्यू f इज इक्वल, जब हम t का वैल्यू 0 पुट करेंगे तो f न्यूटन 0 आ जाएगा. The three-cylinder single-acting engine has its crank at 120 degree. The turning moment diagram of each cycle is a triangle for the power stroke with the maximum torque of 60 Newton meter at 60 degree after the dead center of the corresponding crank. There is no torque on the return stroke. The engine runs at the 400 rpm. The power developed will be. तो पावर डेवलप्ड, जैसे कि पता है, एनर्जी प्रोड्यूस्ड बाय इन वन साइकिल पर सिलेंडर बराबर एरिया ऑफ टर्निंग मोमेंट डायग्राम, यानी कि 1/2 पाई इंटू 30 पाई जूल. Total energy produced by the three cylinder is 90 pi. Mean torque, total energy produced per cycle by angle rotated by the crank per cycle, 90 pi by 2 pi यानी कि 45 न्यूटन मीटर. n mean is बराबर, n mean is equals to 400 rpm. Power produced is equals to t mean into omega mean, 45 into 2 pi into 400 by 60 यानी कि 1885 watt. Primary unbalanced force due to inertia of reciprocating parts in a reciprocating engine is given by mr omega square cos theta. Primary unbalanced force due to inertia Fp is equals to mr omega square cos theta, and secondary unbalanced force due to inertia is Fs is mr omega square cos 2 theta by n. Balancing of industrial rotors in a balancing machine is usually done at a speed between 400 rpm and 700 rpm because the industrial rotator have lateral critical speed more than 5000, and second is balanced rotor have no critical speed. Balancing of industrial rotor in a balancing machine is usually done at speed 400 rpm and 700 rpm because industrial rotor have lateral critical speed more than 500 rpm, and the rotor balanced for 400 rpm to 700 rpm will still balanced for more than 5000 rpm. Balanced rotor have no critical speed. Thank you.